Hello students, so let's try to solve one more problem from JEST 2022 and this is from C part question number 1 and this is one of the wonderful question. So let me first explain you this particular question. So there is two rod which has mass m and they are just hinged at this particular point. So we can assume this point is O and at initial stage, they are just making angle 2 pi by 6 between each other. So this is initial stage and the mass of both the rod is m. So it is given mass of both the rod is same. Both the rod is same. So we can assume that is some m. The length is 1 meter. So we will first solve for L length and then we can put it for L is equal to 1. So length, we can assume that L is equal to 1. So length is L is equal to 1 meter. Initial situation is that the angle between them is 2 pi by 6. So this is your initial situation. And what we have to do, we have to calculate the basically speed of this hinge when this rod is completely, and this rod is just uh, this two end is frictionless. So what will happen? This rod will just slip on this horizontal surface, and this point will come down, and finally it will just become flat. So when it is just going to flat, then what will be the speed of this particular point O when it is just going to be flat? We have to calculate that particular thing. So this is one of the very interesting problem. So let's see how we will approach. So what is idea? Idea is that we will just use the conservation of energy. So initial stage when rod is static at this situation, we have only potential energy. So to calculating this potential energy, we have to find the position of center of mass of the system. And after then, when rod will become completely static, means something like this. When rod will become something like this, then these 2 points will remain stationary and it is just about to touch the ground. That particular point, we can assume the rod is doing something like pure rotation of this point. And so we have to just figure it out what will be the kinetic energy of this particular point. And the beautiful part is that when this rod will become flat, this hinge is at the point of center of mass. So this is one of the very interesting thing. So we have to just go for initial condition and final condition. The first duty is that we have to calculate the position of center of mass. So if we have this sort of information, and we can assume this, and it is given actually 2 pi by 6. So we can find that this angle is nothing but 2 pi by 3. So this angle is 2 pi by 3. And independently, the center of mass of rod is at the center, that is at M, and center of mass of this rod is at the center M. And if we will see the complete picture, the x part of the center of mass of the whole system is at the 0. That means the center of mass is just changing along y. So at this some point, our center of mass will be at the initial position. So we have to calculate this particular length, and this is ycm. So we have to calculate ycm first. So how we will calculate? We will calculate this distance, we will calculate this distance, and we will just subtract it. So what will be that distance? So that this distance is L. So we have L cos 2 pi by 3 minus this distance is L by 2. So that will be L by 2 cos 2 pi by 3, and this is my y center of mass. So for that, we can easily calculate this value is L by 2 cos 2 pi by 3, and 2 pi by 3 is nothing but cos 2 pi by 3 we can easily find that is 1 by 2. So that is L by 4. So we have y center of mass is L by 4. So first thing we have find the position of center of mass along y-axis, and due to symmetry, this is the center of mass is at the y-axis, not it is shifting towards x-axis. Okay, so first thing we have calculated. So initially the rod is static. So what we have to do, we can easily calculate the potential energy. The potential energy is the 2m, the mass of the whole system will concentrate at the center of mass. So 2m g into y center of mass, and that value is equal to 2m g into L by 4, that is mg L by 2. So we have calculated the initial potential energy. Now when rod will become flat, then the total potential energy will convert it to actually kinetic energy. And that time when it is going to flat, we can assume these two rod is just doing the pure rotation about their end, because this end will become rest and we have pure rotation. So we have to calculate the kinetic energy and this will be at the time when rod is going to flat. This is nothing but the velocity of center of mass. So if we are going to calculate the velocity of center of mass when the rod is going to be flat, then we can easily use this particular concept of kinetic energy. So what will be kinetic energy? The kinetic energy is half m VCM square plus half ICM omega square. So what we have to do, we have to find the ICM about this point. So this is my center of mass. So we have to find moment of inertia about this particular point for both the rod. So obviously both the rod is symmetric. So this will be 2 into ml square by 12. So that is center of mass of the rod. The moment of inertia about center of mass of one rod. 2 is due to second rod. Plus we are using the parallel axis theorem. So we have ml square by 4. So we have basically 2 into ml square by 3. So this is ICM. And what will be our omega? We can easily calculate our omega. Hence, at the point when rod is just going to touch the surface, these 2 points are stationary. So we can assume this is something like pure rotation. So we have VCM is equal to omega into R. So this will be VCM by L. This is my omega. Now we will put it here. So when we are just going to put here, then this will be half, and this will be not m, this will be basically 2m. Why? Because the whole mass is concentrated at the center of mass. So this will be 2m, and velocity of center of mass we have to calculate, that is VCM square, and I can use this space actually. So let's use all this space. So T is equal to, so again, please correct it. This will be 2m. So this will be half 2m VCM square plus half 2 into ml square by 3 into omega is nothing but VCM upon L whole square. Then L will be cancel out. This 2 will be cancel out. So we have basically this 2 is again going to cancel out. So we have basically this kinetic energy, this 3, so 4 by 3 m VCM square. So this is kinetic energy when the rod is just going to hit the surface, the flat surface. Now we can easily use conservation of energy. The total potential energy will convert it into kinetic energy. So I can use this space actually. So V is equal to the kinetic energy at the final position. And what is my potential energy? Is mgl by 2, and this value is 4 by 3 m VCM square. So this is your final calculation part, and m can be cancel out, and we have basically VCM. I can use this space. So VCM is equal to root under 3 upon 8 G upon L. We can put the value of G, we can put the value of L, and this G is equal to 9.8. So this will be 3 by 8 into 9.8. L is equal to 1. And you can use calculator. I have calculated it. That is 1.92 meter per second. So this is 1.92 meter per second. So our answer is basically VCM is equal to 3 by 8 G upon L, and that value is 1.92 meter per second. That value is VCM, and that is actually speed of hinge. So this will be the speed of hinge, and this is also speed of hinge. So it's a wonderful problem. So the catch is there. Whenever you are talking about center of potential energy, you have to talk about center of mass. And when you are going for the kinetic energy, then you can see the complete kinetic energy, the kinetic energy of the center of mass, and kinetic energy about center of mass. And you can easily solve this particular problem. So this is one of the very nice problem. We can easily, but this is very nice to solve this one. So just check it. If there is any error or anything new you have to add, please mail us or write into comment. Otherwise, I think this is a correct option. Thank you.